Assalamualaikum class. So today we are going to learn about the new subtopic. But before that, I would like to ask you guys, do you ever wonder why astronaut feels lighter on the surface of the moon compared to the earth? And why astronaut can float on the surface of the moon but cannot on the surface of the earth? It is actually because of gravity. The gravity will affect the weight of the object. So, what is weight? That is what are we going to learn today, which is weight. Okay, class. So first, let's see the definition of the weight. The first definition of weight is vector quantity which has the same direction with gravitational force, which is towards center of Earth. When we talk about towards center of Earth, means that the direction is always going downwards. This is the object, and the direction of weight is always going downwards. Okay. Okay, class. The second definition of weight is the force of gravity acting on object. So from this definition, we know that weight is one of a force. Okay. Weight is a force. So guys, do you clear about the definition of the weight? So please remember, weight is a force, okay? Weight is berat, but it is not berat yang you guys always ask your friend, berapa berat you tu. That is not weight, okay? So that is mass. Weight is a force, remember that. Okay, so clear about the definition, let's move to the formula. So what is the formula of weight? The formula of weight is W is equal to mg, which is W is weight, M is mass, and G is gravitational acceleration or gravitational field strength. The formula for weight is W is equal to mg. So W is weight, and since weight is a force, so the SI unit for weight is Newton, and M is for mass, so the SI unit is always kg, and G is gravitational acceleration or gravitational field strength, and the SI unit is Newton per kg. Okay class, before this we already know about the gravitational acceleration value, right, in the subtopic of free fall motion. So in the previous subtopic, we know that the gravitational acceleration is 9.81 meter per second squared, right? And in this chapter, the value of gravitational acceleration is also 9.81 meter per second squared. And the value of gravitational field strength also 9.81, but the SI unit for gravitational field strength is Newton per kg. But class, you need to remember that 9.81 Newton per kg is the gravitational field strength for the Earth only, and the gravitational field strength on the surface of the moon and in the deep space is different. So what is the gravitational field strength value for the moon and deep space? Okay class, so let's move to the gravitational field strength value. So we know that the gravitational field strength value for Earth is 9.81 Newton per kg, or sometimes the question gives us 10 Newton per kg. So if the question gives us the value of gravitational field strength of Earth 9.81, so we need to use 9.81. But if the question gives us 10 Newton per kg, so we need to use the value of 10 Newton per kg. But if the question didn't give us the value of gravitational field strength for the Earth, then we need to use a 9.81 or 10. Okay, so the gravitational field strength for the moon is 1/6 of gravitational field strength of Earth. So means that 1/6 times with 9.81, then we have 1.667 Newton per kg. So this is the value for gravitational field strength for the moon. And the gravitational field strength on the deep space is 0 Newton per kg. It means that in the deep space, there is no gravitational field strength. Okay class, let's do some exercises. first exercise, a 10 kg object has a weight of 150 Newton on a planet. What is the gravitational field strength on the planet? Okay, first of all, we need to determine what the question asks us. Okay, so the question asks us what is the gravitational field strength. So to find the gravitational field strength, we need to use the formula W is equal to mg. Okay, G is gravitational field strength, right? So what is the information that the question gives us? So the first one is 10 kg object. It means that mass is 10 kg. Okay, the second information is the object has a weight of 150 Newton. So it means that W is 150 Newton. So by transferring the information to into the formula, we have W is equal to mg. W is 150 is equal to 10 kg times with G. So from that we have G is equal to 150 divided by 10, and we have 15 Newton per kg. Okay, the next question is, an astronaut of mass 60 kg is assigned to explore the moon. What is the astronaut's weight on the moon's surface? Okay, so first we need to determine what the question asks us. So the question asks us to find the astronaut's weight on the moon's surface. So how to calculate the weight? We need to use formula W is equal to mg. Okay, so what is the information that we have? We have the mass 60 kg, and we also have the gravitational field strength G, because we know that the G of the moon is 1/6 of the gravitational field strength on the surface of Earth, right? So W is equal to mg. Mass is 60 kg times with G. G is 1/6 times 9.81. Okay, so the final answer is 98.1 Newton. Okay. Okay class, an astronaut has 490 Newton weight on the surface of Earth and 600 Newton weight on the surface of planet A. Calculate the gravitational field strength of planet A. So the question asks us to find the G value of planet A. So how? We still use this formula, W is equal to mg. Okay, so we label WA for the weight of object on planet A and GA for G value on planet A, and WE for the weight of object on Earth, and GE for gravitational field strength value on Earth. So the mass is same, right? Okay. How to calculate GE? We need to use this formula, right? So we already have the WA, weight of the object on the planet A, which is 600 Newton, times with mass GA. But we do not have the value of the mass, so we need to find the mass first. So how? We use this formula. We use the information for the Earth. So WE is equal to mge. So WE is 419 Newton, the weight of the astronaut on the Earth. So 490 Newton is equal to mass times with GE. The gravitational field strength on the Earth is always 9.81 or 10 Newton per kg, right? So from here we can calculate the mass. So 490 Newton divided by 9.81 Newton per kg. So we have mass here 49.95 kg. Okay. Next, we already have the mass value, so we just need to transfer the information of mass into this formula. So 600 Newton equal to mass 49.95 times with GA, gravitational field strength of planet A. So from here we have GA is equal to 600 Newton divided by 49.95 kilogram, and the final answer is we have 12 Newton per kg. Class, do you understand how to calculate the weight? Okay, last but not least, let's see the differences between weight and mass. Okay class, the last thing we need to know is the differences between weight and mass. Okay, so the first point is about the definition. So the definition of the weight is force of gravity acting on object, and the definition of the mass is the amount of matter in object. Okay, then the weight can change with the gravitational field strength. When the gravitational field strength is big, then the weight is big. Okay, when the gravitational is small, then the weight is small. Then the mass is unchanged, means that when you have 40 kilogram on Earth, then you will always have 40 kilogram on Moon or any place. Okay, so the mass is unchanged. And the weight is vector quantity, which has the weight has the direction and magnitude. Like I said just now, the direction is going downwards. And mass is scalar quantity because it only have magnitude, it doesn't have direction. Okay, the SI unit for weight is Newton, and the SI unit for mass is kilogram. So the first one is definition, which is the weight is the force of gravity acting on the object. And the second main point is the formula, which is W is equal to mg, which is weight is equal to mass time with the gravitational acceleration or gravitational field strength. And the third main point is the value of gravitational field strength on the Earth, Moon, and also the space. And the last one is you need to remember all the differences between mass and weight. So if you guys have any question about this topic, so please ask me through WhatsApp. Okay, bye.